Amazing experiment on double-slit experiment, Part 2. In the double-slit experiment discussed in the previous issue, scientists discovered that observing the path information of electrons can cause the interference fringes of electrons to disappear. The causal laws and common sense of life seem to be ineffective in the quantum world. Scientists have fully utilized their imagination and attempted to form new theories in rigorous mathematical form. One view is that our universe is not unique, but rather has countless parallel universes. At the moment we observe, the universe will split into parallel universes. And we can only see what happens in our universe, we don't know the stories in parallel universes. In this experiment, when an electron passes through a double slit, we observe that the electron passes through one slit, which does not mean that the electron did not pass through another slit. It only occurs in a parallel universe, and we cannot see it at all. But when we stop observing, the motion of electrons presents a probability, ultimately appearing in the form of probability in the world we can see. This is the multi-world interpretation and the Copenhagen interpretation, which believe that the quantum world has probabilistic properties, and this viewpoint can also interpret Schrödinger's cat. Another viewpoint denies the parallel world theory and only uses the Copenhagen interpretation to explain this experimental result. It believes that the quantum world is completely different from our macroscopic world, where everything is uncertain and microscopic particles have superposition states, which can only be described by wave functions, which are commonly understood as probability waves. In the double-slit experiment, the pattern of electrons on the screen reflects the probability density. The denser the number of electrons appearing in a certain area on the screen, the higher the probability density, and vice versa. Before being observed, microscopic particles are ubiquitous waves, a superposition of various possibilities of motion. Once we implement the observation, the microscopic particles will collapse from the state of the wave to a definite state. However, scientists currently do know that wave function collapse may occur after observation, but they cannot determine whether it is caused by the observation behavior itself. Therefore, they tend to consider wave function collapse as a fundamental premise, which is the axiom. Quantum mechanics is so wonderful. Next time, let's talk about Schrödinger's cat.